Okay, so in this video we're going to go over functions. So the questions that we have been given is say for the function y is equals to x squared plus 5x plus 6, we have to find the y-intercept, the x-intercept, c the coordinates of the turning point, and d the question is asking us to sketch the graph. Okay, so for this function that we have been given, this is a quadratic function. So one of the steps that you can take to make your work easier is that first of all, you can just by looking at the nature of the function that we have been given, you look at the coefficient of the x that we have there is positive, hence what you're going to have is something like that. Okay, if it's a negative, let's say we had minus x squared, we are going to have something like that. So that's how you can remember how the graph is going to look like. And again, when you talk about a graph, we say it's in this, okay, we have said it's in this manner, but how do we know that it's not going to come like this? Say we have a turning point here and we have a turning point here. This is a quadratic function, and the highest power that we have of this x is what? Is 2. And for us to know the number of turning points that we are going to have is what? You're going to say n minus what? Minus 1. And the value of n here is just the value of the power that we have on this x, which is what? A 2 minus what? Minus 1. Hence, you are going to have what? 1 turning point. That's what we know. So when you go to polynomials, let's say we are given x to the power 3. Meaning, you are going to have 2 turning points. And how is that determined? You just say n minus 1, where you just say 3 minus what? Minus 1, giving you what? A 2, meaning you're going to have 2 turning points. So that's how you can determine the number of turning points that you're going to have, and the nature of the coefficient is going to help you determine the shape of the graph that you're going to have. Okay, so when talking about the intercepts, we're just talking about where the graph is cutting the y-axis, that is for the y-intercept. Then for the x-intercept, you're just looking for the values of x, where the values where the graph is cutting the x-axis, and those two values we can call them zeros of x, whereby when you find those two values, if you place them in this function that you are given, you're going to get a 0. So if you say x squared plus what? Plus 5x plus what? 6, we are going to get what? 0. So meaning, if I find a certain value of x, meaning the value where the graph is cutting the x-axis, and I place where there is x here, I should get a 0. Those are the x-intercepts that we are looking for. Alright. So now, for us to find we'll start with question A. For us to find the y-intercept, to find the y-intercept, okay, this is our A. For us to find the y-intercept, I'll just say y-int, we must equate, we must let our x be what? A 0. So we are going to get the function that we have right there. So meaning whatever there is x in this function, we should put what? Is 0. So meaning we are saying 0 what? Squared plus what? 5 multiplied by 0 there, plus what? Plus 6. So y is going to be, this is 0 and that is 0, we're going to have what? 6. So meaning the y-intercept is what? Is 6. Alright, so we say y is equals to what? 6. So the second one is asking us to find the x-intercept. So how do we find? So we can factorize this, or we can use the formula. It's up to us which method is which method we know better, and the one that is going to save us time, depending on whether it's a test, an exam, or yeah. So we're going to have x squared plus what? Plus 5x plus what? Plus 6 should be equals to what? 0. Remember we said you're looking for values whereby if we place in this equation, we're going to get a 0. That's what we're looking for. Meaning is those 2 points that cut the parts of the graph that cut the x-axis. Okay, so if it's a quadratic as it is, you're going to have 2. If it's a polynomial, let's say you have 3, you're going to have what? You're going to have I'm going to have three points cutting the x-axis, because you have two turning points. But in this case, you only have what? 1 turning point, because of the index that we have, which is what? A 2 there. So for this part, we are going to use the factorizing method. Our product is what? 6. Our sum is what? Our sum is 5. So looking for two numbers, we multiply them, we get 6, we add them, we get what? 5. And those numbers, without even wasting time, they're just numbers that you can find in the product, and that is what? So we're talking about numbers that can go in the product, which is 6, without leaving any remainder, and we can just pick what 2 and what 2 and 3. So if we say 2 multiplied by 3, 2 multiplied by 3, we are going to get what a 6. Then you say 2 plus what plus 3, you're going to get what a 5. So those are the two numbers that you're looking for, right? So we can say x squared plus we can put the 2x here. You can even put the 3x, still going to be the same. Plus we are going to say 3x here plus what plus 6 is equals to what 0, right? So we're going to look for what is common at this part, here, and this part. You're going to separate them. Okay, so now you're going what is common between these two is what is x. It's like we are factoring this. We are going to have our x inside there plus what plus the 2 there. So when you factor this, you must make sure to say if you expand it, it still give you the same nature that you had before you had to factor it. So x by x will give you x squared, x by 2 give you 2x plus. So you ask yourself, what is common between 3x and 6 is what 3. You remain with x here plus what, how many times can 3 go into 6? It's what, it's a 2, giving us what, a 0 on the other side. So we're going to pick this one and this one and put them together, and if you try to check out, this part and this part are equal, so it's just 1. We just have to pick one. So meaning we're going to have x plus what plus 2. Okay, we open again, we have our x plus what plus the 3 that we have right there equals to what 0. So here now it's up to us to find the value of x, which is very simple. So we're going to say our x plus what plus 2 is equals to 0, or our x plus what plus 3 is equals to what 0. So now we are going to take the 2 on the other side. We're going to subtract by 2, so it's just 2 is equals to what minus 2. So another value of x is that x is equals to what minus 3. So these are the two values of x that we are looking for, such that if we put in this equation, you're going to get 0. So let's try out one. In this case, let's try to use 2. So we say minus 2, we put it in bracket squared, plus what plus 5 open bracket, we put what 2 plus what plus 6. So this is not necessary, though. We are just trying to confirm if what we are doing here was correct. So minus 2 squared is going to give us positive 4 plus what 5 multiplied by minus 2 is what minus 10 plus what plus that. So it's more like I can add this one and this one. That will give me what a 10. So meaning I'm saying 10 minus 10 giving me what a 0. So meaning what we have done here is very much correct. Even if you try out the 3 as well, it still give you a 0. So what we can say in this case is that our x-intercepts, we have what x is equals to minus 2, as well as what x is equals to minus 3. So we are getting all this work that we are doing here is going to help us sketch the graph that we are looking for at the end. Very, very important. So now, for us to find the coordinates of the turning point, we can use this. The coordinates of the turning point, they're just a point where it's a point that involves both the x-axis and the y-axis. And for us to find the value of the x-axis, we can use this one. We can say x is equals to what minus b over what over 2a. Alright, so this is to find the value of x over what of the turning point. So now when you look at this this function that we have, this is our coefficient here, right here in front of x is our a. For the coefficient in front of x here, of course here is x squared, but the coefficient in front of x here is what is our b. Then this is our c. So we can say our a is 1. They didn't have to put it there, but we know there is a 1 there. Then for this one, our b is what 5, and our c is what 6. All right, so we can say here this is what minus, okay. Right, so now we can say minus open bracket, our value of b is what 5, divide by, we do that. So 2 we multiply by what our a is what 1. What you're going to get is what minus 5 over what over 2. Okay, so we can leave it in this manner, or we can divide that to be what minus 2.5. I mean, okay, you can say that would be minus, or we can say minus 2.5. all right, so now for us to find the value of y, we just have to replace this value of x that we have found in the function that we have here. So we have y then here we'll open the bracket. We can put minus 5 over what? Over 2 squared plus what? 5, we open, we put minus 5 over what? Over 2, we close, plus what? Plus the 6 right there. Okay, so we are raising this to a power 2, meaning the power is going to, we are going to raise this, we're going to raise the 5 to power what? Power, we are going to raise the 5 to power 2 and the 2 to power 2 as well, meaning we're going to have what? We're going to have, so what we are doing here is that we are multiplying this by itself 2 times. That's what we are doing. So hence the negative is going to go away. So that would be what? 25 over what? Over 4. Plus what? So here, of course, we are going to have, let's say we're going to have a minus here. We are going to have 5 multiplied by 5. That would be what? 25 divided by what? The 2. Plus what? 6 right there. Okay. So now, what is common on what we have here is, what is the common denominator is what? Is the 4. 4 into 4 is 1. 1 by 25 is 25 minus 2 into 4 is 2 times by 25 is what? 50 plus 1 into 4 is 4 times. 4 times 6 is what? We're going to get 24. So what you're going to have as the end result here is more like, we can subtract this part. This is going to give us minus what? Minus 25. So it's like more like we are saying 50 minus 25 giving us what? 25, but you're still carrying the negative because we are subtracting a bigger number from a smaller number. So meaning we are saying minus 25 plus what? 24 divided by what? 4. What you're going to have here on top is minus what? Minus 1 over what? Minus 1 over 4. So our answer is minus 1 over what? Over 4. Okay, so now meaning our TP, I was just say TP meaning turning point. The coordinates that we have is what? Our value of x is minus 5 over what? 5 over 2. Okay, 5 over 2 comma what? Minus 4, 1 over what? 1 over 4. So those are the values of the turning points that we have. So meaning we have our y-intercepts, we have our x-intercepts, we have our turning point. Hence we can sketch the graph now. We can do the sketching now. Okay, so do it in this manner. Alright, so now here we have to put the values that we got. We have gotten to say the y-intercept is this. The x-intercept, we have what? We have these two. Okay. So our both our x-intercept and both the x-intercepts are what? Are on the negative side. So what we have here is what? We have a minus 3. Say minus 3 there. Okay. Then here we have what? A minus what? Minus 2. Then our turning point happens to be, we say 5 over 2, meaning that to be in between this part. So it's like somewhere here. Okay, it's like we're talking about this part, talking about that part. Then negative on the what? On the y-axis. So we're talking about this part. This part here. So now we are talking about a point where our graph is cutting the y-axis. We have been told to say our graph is cutting the y-axis at what point? At positive what? At positive 6. So we can put our positive 6 right here. So it's more like we are coming from this part, going there, passing through negative 2. Come like that. We make a turn here, going through. Okay. So we can use dotted lines first. We pass through our 6. Our 3. We go like that. Alright, so then we can now join the points that we have You can now join them like that. You can now join them like that. And like that, like that. All right, so now, so that is what we have. We can say this is our what, our minus 1 over what, minus 1 over 4. That is the value of y. This is this, we can say this is our what, minus 5 over what, 5 over 2. So that's how you can draw this graph. Of course, when you're using a pencil or something, it will be very smooth and stuff. Yeah, so that's how you go about answering that question, or any other question that you're given. Just make sure to say you know the nature of remember to say, we said the value of the coefficient that we have on this part is what is going to determine the shape of the graph. Remember to say, we said if it's negative, what you're going to have is something like that. If it's positive, what you're going to have is something like this. And since we had the positive, here it is in this manner. And again, when you look at the value of the index, the value of the index that we have is what, is 2, meaning that will help us determine the number of turning points that we are going to have. And since we have a 2, to find the value of the number of turning points that you're going to have, just say n minus 1. Our n is the value that we have, which is 2 minus 1, giving us what, a 1, meaning we only have what, 1 turning points. But in the other case, let's say it was 3 to the power 4 or something like that, you just say n minus 1, which is 4 minus 1, giving you what, 3, meaning you have 3 turning points. Yeah, so that's how you go about answering that question. Yeah, thank you.